What's up? What's up? We are talking about the least common multiple. You know it as LCM. Now, LCM is only applying to just plain old numbers, while LCD, the least common denominator, that is referring to your fractions. Okay? Oops. Not fractal, fractions. Okay? So, because that has a denominator, so essentially we're using LCM in the denominator. Okay? So, that's all it is. So, LCM referring to numbers, while LCD will refer to fractions. Okay? So, this is where I typically ask the question, and I'm going to show everything to you, is what do they have that I don't have? Okay, so this is typically the question I'm going to ask after I break everything down. So let's say, for example, it wants you to find so it says find LCM of 12, 18, and 30, right? So again, these are just regular numbers, so that's why it's called the LCM. If these were fractions, like 1 over 12, 4 over 18, and 7 over 30, and you're adding them together, now they'll ask for the LCD. Okay, but this is just plain old numbers, 12, 18, and 30, and they want to know, hey, what is the LCM? Okay, so let's first do this. Let's change these colors here. Let's call this 12 to be green. Let's make the 18 to be blue. And let's make 30 to be, or let's try this again, 30 to be purple. Okay, so we want to break these numbers down. What do I mean by breaking them down? I'm talking about factor trees. So let's say, for example, the 12. So factor trees is where we kind of break everything down so that we have prime numbers. So 12, we talked about this before. 12 would be like, let's say 2 times 6. And then you go, ooh, the 2 is already a prime number, so I can just bring it down. However, the 6 is not prime, so therefore I can split that apart to be 2 times 3. So therefore now I have the factors, or the broken down version of 12. So 12 is 2 times 2 times 3. 18 is going to end up, if you're doing this, is going to be a 2 times 3 times 3. And then 30 is going to break down to 2 times 3 times 5. Okay? So, if you look at this, actually, I better not do that. I better do this. Let's look at these as like 3 bags. Okay, and you want all 3 bags to have the same stuff in it. Okay, so that is when I go, okay, so let's look at this bag right here, and I'm going to say, okay, what do they have? I'm going to say, what do they have that I don't have? I have a 2, a 2, and a 3. The blue has a 2, a 3, and a 3. And the purple has a 2, a 3, and a 5. Right? So what do they have that I don't have? Well, if you look at it, how many threes do I have? I have one. How many three does the blue bag have? They have two. So I want another three. Okay? Okay, awesome. Now I have two threes. It matches the blue one. What does the purple bag have that I don't have? It has a 5, so I want a 5. Okay? Okay, so now we're done with that. Okay? So does the green bag have everything that the blue bag has and the purple bag has? Yes. Then I'm going to be this bag here. And I'm going to say, what do they have that I don't have? Okay? So the blue bag has a 2, a 3, and a 3. It has only 1, 2. The green bag has 2 2s. Not the ones that you wear. So I want another 2. Okay? And the purple bag has what? Has a 5. So I want a 5. Okay? All right. So do I have everything everybody else has? Yes, I do. Okie dokie. So now I'm going to be this bag. And I'm going to ask myself, what do they have that I don't have? Well, the green bag has what? Has 2 2s. So I want another 2. The blue bag has 2 3s. So I want another 3. I have a 5. Everybody else has a 5. Awesome. Okay, so now if you look at each bag individually, this bag has a 2 2s, 2 3s, and a 5. The blue bag has what? Has 2 2s, has 2 3s, and a 5. And the purple bag has what? 2 2s, 2 3s, and a 5. So all 3 bags now have the same thing. Is that right? Awesome. If that is the case, that means my LCM would be 2 times 2 times 3 times 3 times 5. So my LCM would be the value of the product of each bag, of one of the bags. It doesn't matter which one. So this is going to be 2 times 2 is 4. 3 times 3 is 9, and then 5. This would be a 4 times 45, which gives me 0, carry the 2, 180. So 180 would be my LCM. Here, let me do it this way. So the LCM of 12, 18, and 30 would be 180. Okay? So it's the product of one bag. So this would equal to, the green would be equal to 180, the blue would equal to 180, and the purple would equal to 180. That's why the LCM is 180. Okay? So now, what I did here in red, if this was LCD, then I would multiply this by a 15, this by a 10, and this by a 6. And we notice that 12 times 15 is 180, 18 times 10 is 180, and 30 times 6 is also 180. And if you're wondering where I got the 15, 10, and 6 from, 3 times 5 is the 15, 2 times 5 is that 10, and the 2 times 3 is that 6. Okay? All right. Like, wow, that's great. Thanks. I feel so much more confused. All right, so let's try another one. Let's try finding another example. And now we're going to find the LCM of just 2 of them. Let's say 6y to the 7th and 12y to the 3rd. Okay, so let's do the same thing. I want to make this green and make this blue. Okay, so let's break each one of them down. The green is going to be at 2 times 3, and then I'm going to have 1, 2, 3, 4, 5, 6, 7. Okay, and the blue 12 is going to be at 2 times 2 times 3. Y times Y times Y. Actually, you know what I'm going to do? I'll bring this y down here. Okay, so here's my two separate bags, right? So I'm here saying, what do they have that I don't have? Right? So look at the numbers. They have two twos and a 3. I have 1 2 and a 3, so I need another 2. I have plenty of y, so I don't have to worry about that. Okay? So then I gotta stand over here and say, what do they have that I don't have? Well, they have a 2, a 3. I have two twos and a 3, so I'm good with the numbers. However, look at the y's. I only have 3 y's. They have 7 of them. So I want 4 more. Okay? So now if you look at each bag, the green bag has 2 times 2 times 3, and then 1, 2, 3, 4, 5, 6, 7. And the blue now has 2 times 2 times 3, 1, 2, 3, 4, 5, 6, 7. So they're both the same. So my LCM is going to be the product of one of those bags. Doesn't have to be both. So the LCM of 6y to the 7th, comma 12y to the 3rd is going to be 12y to the 7th. Okay, because 2 times 2 times 3 is 12, and then y times y times y times y times y times y times y is y to the 7th. Okay, so if you notice with variables, it's pretty easy because it is really the higher power. Okay, so total opposite of GCF. With GCF, with variables, is usually the lowest power. Okay, where with LCMs or LCDs, it's the highest power. Okay, because again, you want both bags to be the same, so you're gonna have to add more y's into the ones that has less y's to make up for it. So there you go. Okie doke. All right. So what if we had a fraction? So let me see here. Let's say I got an example, and I have 7 over 27. Plus 1 over 6, okay? So what I would do is, again, now we're talking about LCDs. Okay, now we're talking about LCDs. So now we are looking for LCD. So in other words, we're just focused on the denominator. So if you look at 27, 27 breaks down to 3 times 3 times 3. And the 6 breaks down to 2 times 3. So I'm going to be here saying, what do they have that I don't have? Well, I don't have a 2. Okay? Then I'm going to ask myself, come over here and ask myself the question, what do they have that I don't have? I only have 1 3. I need 2 more 3s. Okay? So now if you look at these two, this bag right here and this bag right here, does it have the same thing? 1 2 and 3 3s. Answer is yes. So now what I have to do is that 2 is missing on the green, so I gotta multiply this by 2. If I do it to the bottom, I have to do it to the top. On the blue bag, I have the 6 is missing 9. So 6 times 9, because 3 times 3 equals 9. So I got to do it to the top as well. So now when I do this, it's going to be this is going to be a 14 over a 54 plus a 9 over a 54. So now I can add these fractions because I need common denominators. I keep the denominator and add or subtract the top, which is a 23. So there is my answer. Okie dokie. All right. So essentially, that is all this section is about and nothing else. So good luck with that. Again, LCM is talking about if they just give you straight terms, where LCD is just talking about doing the LCM for the denominator of the fraction. Okay, so it only deals with the denominator, because In order for us to add or subtract fractions, we need common denominators. I hope this helps.